Thanks very much. Hello, everyone. My name is Mete Atamel. I'm a developer advocate at Google based in London, and today I want to talk to you about WebAssembly, especially running it outside the browser. The presentation is already on speaker deck, so this is the link, and I'm going to share the link at the end of the presentation as well. I'm also going to show some demos, and they're all on GitHub, and I'm going to share the link of that as well. So you don't need to take pictures except maybe this one if you want the slides later. And the way this talk is going to go is that first I want to talk about WebAssembly briefly, what it is, and why we should care about it as backend Java cloud developers. Then I'm going to talk about the landscape of WebAssembly because it's a really fast-changing and somewhat complicated landscape. So I want to do like quick kind of status on that, like, you know, what do we have today and what's possible today. And after that, I want to talk about different frameworks like WASI and WAGI and WASIX. And by the way, in WebAssembly world, everything is like WA something. So there's a lot of acronyms there. So I'm just going to go through some of those, see what they mean. And finally, I will finish up with some frameworks and also talk about languages, like what languages are supported, what their state is, things like that. So it's like a lot of information. And a disclaimer, I'm not the inventor of WebAssembly. I'm not a contributor. I don't know. I didn't write the WASI spec. I'm just a curious developer who kind of ignored WebAssembly for a while. But then it came to the point where it feels like I shouldn't ignore it anymore. So I started learning about it. And as I did, I took notes and stuff. So it's kind of like bringing my research to you, and hopefully it will be useful to you. And feel free to stop me and ask questions as we go along. I think we have enough time, so yeah, feel free to do that. Okay, so what is WebAssembly and why we should care about it? Well, if you look at the definition of WebAssembly from webassembly.org, basically it says it's a binary instruction format for a stack-based virtual machine, and it's also designed as a portable compilation target for programming languages. So in a way, you take your code, you compile to a Wasm module, and you run that in a virtual machine. At that point, at a Java conference, you're probably thinking, this sounds like something we know, right? Like JVM, Java, like what is this? And yeah, it is similar in that sense, right? But I think the main difference with WebAssembly is that it's not just Java or Java-like languages like Scala and others that you can compile. You can actually compile pretty much any language nowadays. So that's kind of the main difference, and there's a few other differences. But as a concept, it's not a new concept. It's just kind of maybe extending the concept beyond Java. Now, what was the original use case for WebAssembly? Initially, WebAssembly was focused on augmenting JavaScript within the browser, because for better or worse, we're stuck with JavaScript. And I don't know you, but I don't like JavaScript as much because what you can do with it is limited. As a language, it's not that great. So that's why sometimes you need other things. And you know, especially if you want to do things like games and 3D graphics, you use things like Unity, which is written in C#. And you know, you don't want to take that and then try to rewrite that in JavaScript, and it's probably not possible anyway. So what you could do is that you could take that and compile to WebAssembly and run that in the browser in a secure, portable way. So that was the original use case. And that's exactly why I ignored WebAssembly for a while, because I'm not a front-end developer. And even if I do front-end, I don't do games or 3D graphics, so I had little reason to learn about WebAssembly. So I kind of ignored it for a while. But it's been around for a while. And Microsoft, for example, they have Blazor, which is a framework to write C#, basically, C# UI, and run that within the browser. So it's been around for a while, even though maybe we were not so, we were not using it as backend and cloud developers. And all major browsers, they actually support WebAssembly fully. But then I started seeing some tweets and some blog posts on running WebAssembly outside the web. And this was 2019, so not so recent. And then talking about a project called WASI, which is a system interface that we'll talk about. And then the founder or the co-founder of Docker replied with this, where he says, if Wasm and WASI existed back in 2008, we wouldn't even need to create Docker. So when I started seeing statements like this, then I started paying attention. So I said, maybe this is something that's relevant for backend. Maybe it's relevant for microservices for cloud. And there was a survey from CNCF, Cloud Native Computing Foundation, where one of the key findings was containers are the new normal and WebAssembly is the future. So that's when I started paying real close attention, because containers, they've been around for 5 or maybe 10 years, and they've been a big part of how we run code in the cloud, and how we take our code and put it into this context and run it as microservices. So if that's the new normal, and if WebAssembly is the future, we should at least try to learn about it, and at least that's what I thought when I was looking into WebAssembly. All right, so what does Wasm, which is the short version of WebAssembly, outside the browser mean? Well, there's a project called WASI that I'll talk more about later, and the whole point of WASI project is, it's trying to get WebAssembly run outside the browser, right? Because when you run WebAssembly outside the browser, you need to be able to interface with the host, and that's what WASI project tries to standardize and help with. And the idea here is that instead of running applications as within virtual machines or within containers, you can run them faster, smaller, more secure, more portable using WebAssembly modules, right? So when you hear these words like faster, smaller, more secure, more portable, why not, right? Of course, we all want to do that, but what do they actually mean? Well, faster. WebAssembly applications typically start faster than containers with no cold start. And here I didn't put any numbers, because as soon as you put numbers like 10 times faster or 5 times faster, then people start asking questions, and it really depends on the use case and what you're trying to do. But typically, a container or even AWS Lambda function, it needs hundreds of milliseconds to start serving. Whereas Wasm, it is tens of milliseconds typically. So that's the type of scales we're talking about. Smaller. So if you take a Hello World REST application and compile it to Wasm, it's typically smaller than running it in a container. And again, I didn't put numbers, but you can think of it as like 2-3x smaller. So that gives you an idea of how much smaller it is. More secure. So Wasm applications execute in a deny by default sandbox. So if a Wasm module needs to access the host has to enable that. And if the host needs to call the Wasm module, the module has to export the function. So by default, everything is denied, and you need to enable things. Compared to containers, where in containers typically you have this allow by default policy, and then you need to kind of go through this phase of kind of hardening what the container can do. And actually that's why I didn't like containers as much, because I was spending so much time trying to edit my Docker file so that it's more secure, because the default is not so secure. So you need to kind of go through this exercise of like trying to make it more secure. Whereas in Wasm, it's the other way around. And more portable. We don't typically think about this, but when you build your application, you need to compile it for different architectures like Linux AMD or Linux ARM, right? Whereas in Wasm, you just compile to a Wasm module, and that module runs wherever you have a Wasm runtime. So that makes it much more portable. You don't have to compile it for different architectures. So this all sounds pretty good to me. So and then it kind of makes me think that, we went through this phase of, running our software on pure hardware. Then we started having virtual machines. Then after virtual machines, we started having containers running within virtual machines. And nowadays, we have just containers. For example, on Google Cloud, there's Cloud Run, where you basically just say, this is my container, just run it, and then it does the work for you. So you don't even need to think about virtual machines anymore. So maybe the next phase is you have a Wasm module that's lighter, more secure, faster, all that kind of stuff. and then you just run that instead of a container. I mean, is this the future? It's like, it's a question, but I can see things going in that direction. And then at this point, you might be wondering, okay, this is all nice and all, but what can I use Wasm for? I mean, what kind of use cases is good for this kind of stuff? And there's a really nice blog post on Femiron. Femiron is the company behind the Spin framework. I'm going to talk more about that later. But they have a really nice blog with lots of technical details about WebAssembly. And there, Matt Butcher, I think he's the CEO of Femiron, he basically outlined 4 use cases for WebAssembly that I agree. And I kind of changed the titles a little bit to make it more specific. But basically, the browser use case for WebAssembly is well established. All the browsers, they support it. So if you need to run native code within the browser, WebAssembly is great for that. And that's been around for a while. The second area that's coming up, and it's also quite established at this point, is what I call the plugins at the edge. For example, Shopify has something called Shopify functions, where you can customize the checkout process within Shopify. So you can write your code and then customize the checkout process. And for that, they use Wasm. And the reason for that is because, number one, you can use many languages with it, so anyone can write anything in any language. And secondly, the security model of WebAssembly helps for that, because this code that people are plugging in, you don't want them. I mean, you can't trust them, right? So WebAssembly with its like deny by default policy is good for that, because you can let people deploy their functions and only enable them to do certain things. Similarly, Envoy proxy allows you to kind of edit the policies of the load balancing using Wasm. And there's other things like Fastly's Complete Edge. I haven't looked into it in too much detail. But basically, there's this ecosystem of plugins that's coming up that's good for Wasm. IoT is a natural area for WebAssembly as well, because with WebAssembly, what you get, the actual runtime and the actual module, it can be very small, and that's good for IoT devices. And finally, this other part, the cloud microservices part, that I'm quite excited about. It's the new area that's coming up. I wouldn't say it's ready yet, but I can see it as like the next iteration of containers and serverless functions maybe being deployed as Wasm modules. And there are frameworks like Spin from Femiron that really helps with this, and we'll talk more about this later. So these are the 4 main areas that I also see that's good for WebAssembly today. All right, so we talked about WebAssembly, we talked about like WebAssembly outside the browser and why we should care about that. Now let's look into some details. Let's look into Wasm runtimes and WASI spec. Now, as a recap, Wasm is a portable compilation target. So what it means is that you write your code. Typically, you compile your code for the certain architectures, but in Wasm, you compile to a module, and that's it. So that simplifies the things quite a bit. Now, once you have this module, then this module can run on different architectures, but for that you need a Wasm runtime. So kind of like JVM runtime, you have Wasm runtime, but the beauty is that you don't need to change this module. Basically, it's the same module that can run in different places. And these Wasm runtimes, there's a lot of them actually for different kind of things. And the ones that I've seen that's compatible with Wasm and WASI is Wasm time. This is a runtime from Bytecode Alliance. This alliance, it's a body that's working on WASI spec that we'll talk about, and Wasm time supports WASI. Then there's another one called Wasm Edge from CNCF. This is more for running things at the edge, so it's supposed to be really small and efficient, and it also supports WASI. There's another one called Wasmer from a startup, and there's many more actually. So if you go to this link, awesome Wasm runtimes, you can get a full list and you can see these runtimes and what they do and what they're good at, right? But these 3 are the main ones that I've seen in the context of running Wasm and WASI, probably on the server side, kind of like cloud microservices kind of context. Like that's what I'm seeing, but by no means they're the only ones. And then once you have your Wasm module running within the runtime, then you need a way to talk to the host. Let's say you want to write something or you want to kind of interact with the host in some way. The WASI project is trying to standardize on that, because let's say you want to write a file. The way you write a file on Linux is different than the way you write on Windows. So WASI tries to kind of standardize on that and give you a common way of writing those files, and then the runtimes implement that API, and that way they can all run similarly in different hosts. But when you look at WASI, it's POSIX inspired preview 1, so it's still preview 1. It's nothing finished yet, and I think they're also working on preview 2. And it's a very limited number of functions right now. So you can do things like read and write files. You can read program arguments, get environment variables, and a few other things. And they also say there's limited socket support. I don't know what that means actually, because you can't read and write from sockets with WASI, preview 1 at least. So I don't know what it means to support sockets when you can't read and write from it. So it's very limited, basically. That's the point of WASI. Yeah, and most of WASI is actually proposals on how to do things. And if this link, I won't click right now, but basically there's a proposals page, and in there you can see what proposals they are making it and what's the progress on that. But there's no socket support yet, which means you can't really have services like cloud services reading and writing using pure WASI, and that limits what you can do with WebAssembly in the cloud severely. Because of that, some runtimes implement their own sockets. For example, Wasm Edge, they have their extensions for sockets, so they add their own sockets, but these sockets are only supported in Rust and JavaScript and C for now, so it's limited. There are some projects that try to enhance WASI. For example, there's a project called WAGI that adds HTTP handlers around WASI. So the idea here is that you write your WASI module, which is just a console application, but then around that, you can add HTTP handling. And I'm going to show an example of this later. There's another project, which is more recent, called WASIX, that tries to add full POSIX support to WASI, but it's only supported on Wasm runtime, right? And there's a little bit of controversy here, by the way, because WASIX came along because WASI was around for a while, but it didn't add all these POSIX features, so they went ahead and they started adding POSIX, but it's not part of WASI, so because of that, it's not standard yet, but maybe it will be standard, you know, we don't know. So there's always like things happening, with a big but. It only supported on this runtime, it's only supported on this language, stuff like that. There's no garbage collection yet in WebAssembly, but there is a proposal, and so if you go here, you can read more about it. And this will be a prerequisite for languages like Java, for example, where you need garbage collection. So this whole space is very dynamic and changing, and there's standards, but they're not fully there yet. There's projects that are trying to go around it. So when you need to do something, half of the battle is trying to figure out, okay, what should I use next? And then when you start using it, then you realize there's something new that can do things better. For example, I started looking into WAGI, but then I realized that WASIX actually looks pretty good to me. So maybe next I will look at that. But we have to wait and see what happens in this space, basically. All right, so let's just look at a quick demo now. I want to show you how to compile code to Wasm and WASI and run on a runtime and see what it takes. I have this GitHub links where I show how to do this in Rust, in .NET 8, in Go, and then one of my coworkers, he also have one for Kotlin. I don't have Java yet, and that's because Java's Wasm and WASI support is complicated. There is a special VM called TVM that's supposed to support Java within the browser, and then there's a fork of that from Femiron that's supposed to add WASI support to it. So technically, you could run Java using this special fork of TVM, but I thought it's too many hacks together. And that's why I will wait a little bit longer to see what happens there before kind of looking into Java. But let's look into Rust, because Rust is one of the main supported languages in Wasm and WASI, and see what it takes to run that. So here I have a Rust application, and I have a README, so let's look into that. All right, so first what you need to do, and hopefully you can see that. First, what you need to do is you need to have Rust installed, and you need to have a Wasm runtime installed. In this case, I installed Wasm time and Wasm edge. Then you need to add Wasm 32 WASI target to Rust so that it can compile your Rust application to Wasm module. So I did that already. Then you can create a new Rust application in Rust. You can do that by cargo new hello Wasm, and that will create a hello world application. But then I went ahead and changed that hello world application to do something with the host. In this case, I'm just creating a file in the host to show that Wasm can talk to the host. And let me just show you the code quickly. And by the way, I'm not a Rust developer, so I don't know this stuff too well either. But it's pretty easy to read. So if you look at this Rust application, first I'm doing a hello Wasm, so this is just output. And then here, I'm creating a file in /hello world and then hello world.txt. And then within that hello world.txt, I just write hello world. So something very simple. So the key here is that I'm doing this /hello world. For me to be able to do that, the host has to enable it. So the host has to say, okay, you can write here, and with that I will be able to write there. So once I have this, what do we need to do to compile it? Well, you can do cargo build and then pass in a target. So actually, let's do that here, so you can see that it works. So if I do samples, Rust, and then cd hello, and then let's do cargo build, target Wasm, and I already built it, so it's finished already. And this basically creates, if I do, yeah, you see that it created a Wasm module. And then I need to run this, but to run it, I need to enable the module to have access to my host. So to do that, it depends on the runtime. So in Wasm time, you need to pass in this map directory flag, and then here I'm saying /hello world. So this is in the Wasm module. So whatever the /hello world in the Wasm module maps to dot, meaning this directory on my host. So that's how I enable things. So if you actually copy this and run Wasm time, you see it says hello Wasm, and then created hello world txt. And then if we, where did it create? Somewhere here it created, oh here. Yeah, so it created the file. And then you can do the same with Wasm edge. So that's another runtime. And there you see the flag is different. So every runtime will have their own flavor. But if we do that, it will do the same thing, right? So that's good. And if we want to do this, let's say in another language like Go, let's look at that one. In Go, it's slightly different. What you need to do first is Go doesn't support Wasm modules yet. It will support it in the next version, which is in preview. But there's something called TinyGo that you can install that supports it. So I installed TinyGo. And then I created the same application. So let's look at the Go. Again, I'm not a Go developer, but the code looks pretty similar. So we are doing print out, and then we are creating a file again to /hello world, a hello world txt. And then to run this, first we need to build it for Wasm and WASI. So here you would do TinyGo build and then pass in the target. This time the target is WASI instead of Wasm WASI. So you see everyone is doing their own thing. But let's do that. So Go Wasm, and then yeah, I already compiled this. You see that there's a Wasm there, but let's do it anyway. And then once it's compiled, you have this Wasm file, and again you can run it just like you did before, right? And hello Wasm. Now this time we went from Go to Wasm, and you can even do it for .NET 8. .NET 8 they added support For Wasm, they even have a template, and then you can do the same kind of thing. So it's cool to see all these languages kind of having their own slightly different ways, but in the end, you get a Wasm module, and you can run that with the runtimes that you have. All right. Now next, let's look into running these WASI applications in Docker. And at this point, you might be asking this question, like, why take something that's smaller, faster, more portable than a container and run it inside Docker, right? That's a question. And it's a legitimate question, but I think the answer is that we have this whole ecosystem around Docker and Kubernetes, where you can build images, you can push those images to registries, you can pull them, all that kind of stuff. We don't want to throw those away and build a whole new ecosystem around Wasm. So instead, I think what Docker is trying to do here is that it's trying to combine this ecosystem with the benefits of Wasm. So that's why it might make sense. But I think, and right now, like, you run a Wasm module as a container, but maybe this will evolve to the point that where you are just running Wasm as is without having to put it in a container. So we'll see how this evolves, but I'll show you what the status is today. And there's a project called runWASI, and this project, it tries to facilitate running Wasm managed by containerd. So containerd is a thing that manages to runC, which basically runs containers. So runWASI tries to make containerd run Wasm modules, basically. And starting in 4.15, Docker uses runWASI to run Wasm with Wasm Edge, Wasm Time, Spin, and Slide runtimes. So I already talked about Wasm Edge and Wasm Time as runtimes. Spin is a framework, but apparently they have their own runtime, so that there's a runtime for that. Slide is another framework, Wasm framework, that I keep hearing about, but every time I look into it, I don't see much there. So I don't know why there's so much emphasis on Slide, but it's there, and they probably have their own runtime. So Docker supposedly supports all these runtimes. Unfortunately, I only got it working with Wasm Time. It didn't work. Sorry, Wasm Edge, I think. It didn't work with the rest because I'm missing some shims. So maybe someone, if you know this stuff, let me know. Maybe I'm missing something. And then Azure also, in their Kubernetes service, they are using runWASI to support Spin and Slide on Wasm Time, right? So there's stuff happening here, and actually there's this really nice blog post from Nigel. He's been talking about WebAssembly quite a lot and explains all this stuff really well. But basically, the gist of this is that typically you have containerd managing runC, and runC creates and manages containers, and that's the idea. And then what's been happening is that instead of having runC, now we can have Wasm runtimes, and containerd basically uses these Wasm runtimes to run Wasm assemblies, Wasm modules. And here, this is done through shims, basically. In a shim, you have the runWASI, and you also have the Wasm runtime, and that's how you can run things within containerd, right? So you can read the details here, but basically this is the idea. All right, so now let's look at how to run the same application, but now within Docker. So if I go back to my code, now I have the same. Well, first I need to let you know that you need Docker Desktop for in 15 or later, and you also need to enable containerd in Docker because you need containerd to be able to run Wasm. So you need to enable that. It's an option in Docker Desktop. You kind of create and build a Rust application just like before. In this case, I'm not doing anything fancy. I'm not doing file system. I'm just doing this. So I'm basically saying hello Wasm before, wait 3 seconds, and then do hello Wasm after. And so once we have this application, we build it just like before. So let me copy that, and let me go to Rust, Wasm, Docker, hello Wasm, and build. So that's built already, and we can run this locally just to see that it works. And you see it says hello Wasm before, wait 3 seconds, and then it will say hello after. Okay, that's good. Then you enable containerd in Docker, and I show you how to do this here. Then you create a Docker file, and if you look at our Docker file, you see we are basically depending on nothing, like, because we are not going to rely on any image. We are just copying our Wasm module and just running that straight. So that's all we do here. And then you can build the image just like before, just like any other container. So Docker build. Oh, I don't have Docker running. That's a shame. So hopefully this won't take too long. All right, so hopefully it will start soon. But in the meantime, I can explain you how this works. So you build it, and then you can just run it like this, and you pass in a runtime. So here, as you see, I'm passing a runtime with Wasm Edge, which means container will use Wasm Edge to run my Wasm module, and in the end, you'll see my hello world before and after. This output is wrong. I'll fix this later. This is supposed to work with Wasm time as well, but I couldn't get it working because it's, as I said, like it's telling me that there's a shim missing, and there was no instructions on how to install that. So I'm not sure if I'm missing something or if it's Docker missing something. And then once you have that, you can push the image just like you push a regular image, and you can pull it and all that kind of stuff. So let's see if Docker is up. Okay, yeah, it's building, so it's built. And then if I do Docker images, you can see my images there. And then if I open, let's make this, okay. And then if I open like a new terminal, and then let's do Docker run. So I'm doing Docker run here. And then in this terminal, if I do Docker PS, I wasn't fast enough. So Docker run, Docker PS, so you see there's a container ID and so on and so forth. Now, are we running in containers? I guess technically yes, because I have container ID and all that. But at the same time, it's nothing but the Wasm module. So maybe it's just running like the Wasm module, but it's not like pure Wasm module, I think. It's just wrapped in a empty container, basically. So I'll see how this evolves over time, but this is the kind of support you have in Docker today. All right. Next, let's talk about WAGI and WASIX and what they are. So far, as you've seen, we create this console applications, and then they just print some stuff and they access to the file system a little bit, but you can't do anything useful like running like a web application or reading HTTP or anything like that. And that's why you have these projects coming up like WAGI. WAGI allows you to run WASI binaries as HTTP handlers. The idea here is that you write your command line application and you print some special headers, and then you compile it to WASI, and then you also specify a modules file, and in this modules file you map your paths to your Wasm module, and then WAGI kind of routes those requests for you. So it takes care of HTTP for you, and then it routes the request to the right module. And then there's this other project that came up recently, WASIX, that's trying to extend WASI with most of the missing POSIX features. And as I mentioned before, it's controversial because it's not part of the WASI spec. Maybe it will become standard, maybe not, but it's something to look into. It's only supported on Wasmer runtime, so I haven't looked into it yet, but it's basically allowing more real-world applications with networking and multi-threading and so on and so forth. So it's something to definitely keep an eye on. All right, so now let's look into how to run WASI binaries with HTTP handlers with WAGI. And see how that works. So if we go back to our sample, here I have something called hello WAGI. So let's open that and let's close others. Let me make this smaller. So let's see how this works. So again, you need to install a runtime and you need to install WASI. It's basically just downloading a tar file and so on and so forth. Then you need to create your WASI modules. In this case, I'm creating two modules in two languages. First, I create a .NET application, and here in this .NET application, like this is how you create a new Hello World .NET application. Then they have this WASI SDK package that you can add so that you can compile this to Wasm. So I added that. And then I changed the program.cs. So let's look at that actually. So here I'm saying hello WASI from C#, but then I also added these two lines. So you need to add the content type, and then you also need to add an empty line. That's the requirement from WASI, right? So by doing that, you are kind of making this kind of ready for WASI. And then once you build it, you will get a Wasm module. And let me see if I have this built. So hello WASI, and then .NET build. Now this is using .NET 7 preview. Well, actually it's using 8 now. But in the end, I will have a Wasm module that I will use. And then you can run this in Wasm time just like before, but we don't have to do that right now. Then I create a Go application for WASI, and again here it's very similar. So if we look at the Hello WASI Go, this is a hello world, and then we add the content type with the empty line, same as before. And then we use TinyGo again to build it. So let me just double check that this is actually built. Yeah, so I see the Wasm here. So that's built as well. And then to run it as a WASI module, we need to create this modules file. And in modules, we are basically saying, okay, this /C# points to this Wasm module, and then /go points to this Wasm module. So I'm mapping paths to my modules. So we specify that, and then we run it with WASI-C modules to run it within WASI. So let's actually run and see that it works. So I'm running that, and now it's running on this URL. And then if I do curl and then C#, I see that it's hitting the C# module. If I do go, now it's hitting the go module. So this is one way of adding. How do I get rid of this? Let's kill it here. Okay. This is one way of adding HTTP around your WASI through this project. And as I mentioned, WASIX is another one, and I will probably write a demo of that later just to show how it works, but that's only on Wasm runtime. All right, so in the last part, I want to talk about the frameworks and languages in this area. There's a lot of Wasm frameworks out there, and they do slightly different things depending on what you're looking for. But one thing that I've seen is Spin, which is an open source framework by a company called Femiron. And it seems to be the most comprehensive and relevant kind of framework for Wasm services. So if you're thinking about Wasm services running in the cloud, then this is the framework that I would look into. Spin handles all the HTTP requests and response handling using WASI in some cases for some languages, and then I think they have their own framework as well for other languages. There are SDKs available in Rust, Go, and other languages. And basically, any WASI compatible language you can run with Spin. So if you're looking to play with Wasm, or as a service, then I would definitely check out Spin. And I have an example of how to run Python with Spin. So maybe I can go through that quickly to show you that how that works. So if you want to run Python with Spin, Spin tries to kind of like simplify things. So instead of like trying to figure out the runtimes and all these different plugins to compile your code to Wasm module, they give you all the tools so that you don't need to worry about anything but Spin. So that's the idea. So for example, for Python, you first install Spin, and then once you have Spin, they have this Spin plugins framework. So you can do Spin plugins install py2 Wasm. So this is to compile Python to Wasm. So you install that, And then Spin comes with a lot of different templates. So actually, if you look at that, if I do Spin new, you see there's all these templates like HTTP Go, HTTP JavaScript, PHP, and Python is one of them. So you can start with these templates and get some code by default. So that's what I did here. So I do Spin new HTTP Python, and I define my paths and everything. But in the end, basically, what you get is this simple Python application that receives a request, which is from Spin, and then it just returns 200. And you see this content type text plain. It looks like it's using WAGI under the cover, so that's why we need to add this content type, I think. So that's Spin. And once you have that, you don't need to worry about how do I compile Python to Wasm, what do I need to install. You can just do Spin build. So let's actually do that. Where is it? Python. And then if I do Spin build, then that takes care of all the details of, like, calling the right things and then creating the Wasm module for me. And then if I do Spin up, that will start up my application. And if you go here, then I see hello from Python SDK, right? So it's a really good way of running services. And then Femiron, they have services where you can take this and deploy to the cloud. I haven't looked into it, but it's something to keep an eye on as well. All right. Okay, and then lastly, the language support. So what languages are supported in this Wasm and WASI world? This is a very complicated topic. Because if you look at this link from Femiron again, they have this nice table where you see the language, and then you see the support in the browser, then you see the support in WASI, and then you see the support in Spin. So for example, if you look at Java, it says, there's support for WASI, so it makes you think that, okay, I can run Java really easily with WASI, which is technically true. But to be able to run Java within WASI and all that, you need to have a fork of the TVM from Femiron, and then you can only run things that are not multi-threaded and all that kind of stuff, right? So so it's not like you can run the full Java using the regular tools. You need to rely on a lot of custom things to be able to do that. Similarly, Go, as I mentioned, you can run Go and compile using TinyGo, but you can't do multi-threading and all that kind of stuff, right? So I think this is kind of misleading, basically, is my point. From what I've seen, Rust, C, C++, they're the main languages that have excellent support for Wasm and WASI right now. For rest of the languages, they're supported through some hacks and things, like, for example, C#. They added this WASI SDK for .NET 7, but then in .NET 8, they changed things, so it's kind of different between .NET 7 and .NET 8, so we need to see how that evolves. I already mentioned Java. Kotlin, they are supported via this project, but I think it needs Node.js. So you see it's a mess, basically. And I think we need to wait a little bit to see how they all come together and how things are supported by default, like in Rust, for example. In Rust, it's very straightforward. You just install this special plugin, and then you have support for things. But even in Rust, you still don't have support for multi-threading and all that kind of stuff. So we still need to wait and see how this evolves. All right, so I'm almost out of time, so a few conclusions before I finish. So Wasm outside the browser is a very fast-changing space. Every time I look into it, there's something new to look into it, and even the things that you have, they change. So what I show today, maybe it won't be true tomorrow. So we need to keep an eye out on things. The standards and languages, the support needs to mature for Wasm microservices. So if you are looking into running Wasm microservices today, I think we need to wait a little bit. It's still very experimental, but I'm guessing that within a year or so, things will mature to the point that maybe we'll see these becoming more production ready. Will it replace containers? Maybe. I don't know. I think there's potential, because if you can take the same code and compile it to Wasm and get it running in a faster, more secure, and more efficient way, why not? So it has the potential, I think, to replace containers, but it's not there yet. So we'll see how the ecosystem evolves basically around WebAssembly. But definitely it's exciting time to learn this new technology and play with it and see what happens. So hopefully we'll see a lot of progress in this area in the next couple of years or so. All right, so thanks very much for listening. So as I mentioned, the slides are here. All the demos I show, they are here, and I will keep adding as I learn more. This was the first time I ever did this talk, so if you have any feedback about the talk, or if you want to hear more topics in this area, please send me feedback. I always appreciate that. Yeah, so thank you for listening, and if you have any questions, we have some time, so I'll be happy to take any questions that you might have. Thank you. Yes. What about support for user interfaces? So user interfaces within the browser, you mean? Okay, so within the browser, there are things like Blazor, for example, from Microsoft for C#. So there's that. For the rest, I don't know, because I haven't done much work in the browser side of things, but I'm sure there are things there, because WebAssembly has been around a while in the browsers, so there must be some frameworks for user interfaces there. On the server side, I haven't seen anything like on the desktop side. Let's say I haven't seen anything for user interfaces yet, but maybe there will be. I don't know. Okay, and that runs on a desktop with WebAssembly or something like that. Okay, yeah. So in Rust, it runs in the browser as well. Yeah, and I mean some of these things, like even though they run in the browser, they could run outside the browser, like if they don't need to do anything special, right? So some of these things, they might be already running, but we just haven't done it outside the browser yet. Anything else? All right, then enjoy the rest of the conference. Thank you.